Hello students, this is your chemistry mentor ready. So today I am going to start chemical kinetics. So what is this chemical kinetics? So kinetic means velocity. So this particular chapter is representing the velocities of chemical reactions or speeds of the chemical reactions. So kinetic means speed. Speed or rate of reaction, speed or rate. Therefore, this particular chapter is explaining speeds of chemical reactions or rates of chemical reactions or velocities of chemical reactions. So actually this chemical kinetics is dealing about the reactions of moderate reactions. So why this chemical reactions, chemical kinetics is dealing about velocities of reactions, moderate reactions only. Why it is? For example, based on speed or rate of reactions, there are different types of chemical reactions. So based on rates of chemical reactions, reactions dividing into three different types. Three types. Number one is very fast reactions. Number two is moderate reactions. Number three is very slow reactions. So based on rates of chemical reactions, reactions dividing into three different types: very fast reactions, very moderate reactions, very slow reactions. So now let us discuss the very fast reactions. So what are very fast? So reactions which completed in very few milliseconds or in very few seconds. Reactions which completed in few seconds or in few milliseconds or called as what? Very fast reactions. For example, most of the inorganic reactions are very fast. For example, NaCl plus AgNO3, this is ionic reaction. So generally it is very fast reaction because in sodium chloride already we have the separated ions Na plus and Cl minus. These two ions are already separated. No need to separate the Na and Cl. And also here this is Ag plus and this is NO3 minus. That's why all these are already separated. That's why there is a reaction taking place within fraction of seconds. So you will getting what? NaNO3 plus AgCl. So AgCl is a white PPT. That's why it is a very fast reaction. Already it is the ionic reaction and it is an example of very fast reaction. Now let us the second type, it is the moderate reactions. Moderate reactions. What are moderate reactions? So reactions which completed in few minutes or in few hours. So such type of reactions are moderate reactions. Suppose a reaction, for example, most of the covalent reactions, covalent or organic reactions, most of the covalent or organic reactions are moderate reactions. Why these are moderate reactions? For example, if you take CH3 COO CH3, this is the methyl acetate. It is an organic compound. It is a covalent compound. Now react with water in the presence of acid. Acids generally representing H plus. So there is a reaction between these two. You will getting the acetic acid CH3COOH plus CH3OH. So this particular reaction is a moderate reaction. So why it is moderate reaction? So in this ions are not separated because bonds are covalent. So in between the carbon hydrogen or in between the carbon and oxygen, all these bonds are covalent bonds, and H2O is also a covalent molecule. Therefore we need some energy to break these bonds. That's why this reaction occurring under moderate conditions, moderate timings. For example, few hours or in few minutes. And one more example, example number 2, it is saponification reaction. So what is saponification reaction? For example, CH3 COO C2H5, this is the ethyl acetate. Upon reaction with sodium hydroxide, this is the base catalyzed hydrolysis of ethyl acetate. This is ethyl acetate. This is the reaction of a base catalyzed reaction. CH3 COO Na, this is the sodium acetate. You will getting sodium acetate plus CH3COO Na plus C2H5OH. So this is the moderate reaction. And one more reaction, inversion of cane sugar. All these reactions are under organic or under covalent reactions. That's why they are moderate reactions. So inversion of cane sugar means cane sugar is the C12H22O11. On reaction with water, this is the hydrolysis generally occurring in presence of acid. So you will getting the C6H12O6 plus C6H12O6. So one is glucose and another is the fructose. So all these reactions are covalent reactions. All these reactions are covalent or organic reactions. Their rate is moderate to very fast and very slow reactions. And now the third type, it is very slow reactions. So what are very slow reactions? So reactions which are completed in reactions which are completed in few days or few months or few years. So such type of reactions are very slow reactions. For example, rusting of iron. Rusting of iron is an example of a very slow reaction. So rusting of iron means iron exposed to air and moisture. Air means O2 and moisture means water. So this is X moles water. So now we will getting the rust Fe2O3. Fe2O3 dot X moles water. This is the rust. Rust formula is like this only now. So this is 2 moles iron and this is 3/2 O2 oxygen and X moles water. This is the rust formula. So iron when exposed to air and moisture, you will getting the rust. So for this rusting of iron, we requires some days or some months or some years. That's why it is very slow reaction. Now we are going to discussing about the kinetics of 3 different types of reactions, like very fast and very slow and moderate reactions. Suppose kinetics of kinetics. So kinetics of very fast or very slow and moderate reactions. So which one is correct? So now we are going to explaining the kinetics of very fast, very slow and moderate. Actually, kinetics of very fast reactions and very slow reactions cannot be studied, because either they are too fast and they are too slow. That's why we cannot study the kinetics of very fast and very slow reactions. But kinetics of the third type, it is the moderate reactions, can be studied. Kinetics of very fast and very slow reactions cannot be studied. Reactions cannot be studied. Why they are why they cannot be studied means because their rates are very fast or very slow. They are very fast or very slow. But kinetics of moderate reactions can be studied. Because it is not like very fast or not like very slow. Therefore kinetics of moderate reactions can be studied. So now we are going to discuss our chapter is only for moderate reactions. So now so kinetics chapter is applicable only for kinetics of reactions, applicable only for moderate reactions. It is not applicable for very fast and also not applicable for very slow reactions. And after this we are going to discuss some terms in this kinetics. The first and one and only the most important term is the rate or rate of reaction. Rate or rate of reaction. So what is this rate or rate of reaction? Actually it is the ratio between the change in concentration of reactants or products to the change in time or time interval. For example, rate generally it is represented by R, it is equal to the change in concentration. Change in concentration of reactants or products to the change in time or time interval. So rate generally it is represented by R, it is equal to change in concentration of reactants or products by change in time or time interval. So actually this R is equal to change in concentration means DC. D means change in concentration of reactants or products by change in time. This is R equal to DC by dt. So there are alternative definitions to this rate now. So rate is nothing but alternative definitions to rate. Alternative definitions to rate or rate of reaction. For example, if you consider a reaction, consider a chemical reaction. A gives P. This is the one chemical reaction. Now you consider this chemical reaction. A gives B. A is the reactant and B is the product. So initially concentration of reactant A is high. Initially concentration of any chemical reaction, concentration of any chemical reactant is high, and at the same time concentration of product is zero. As time increases, concentration of reactant gradually decreases, and concentration of product increases. So basing on this, initially if you take any reactant, the reactant concentration is high, at the same time concentration of product is zero now. As time increases, concentration of reactant gradually decreases and concentration of product gradually increases. So for example, when a graph is plotted between the concentration of reactant or products on y-axis and time t on x-axis. So initially the concentration of reactant, this is the reactant concentration, this is very high at initial time. As time increases, concentration decreases. At the same time, concentration of product gradually increases. So like this now. This is the concentration of product and this is the concentration of reactant. Thus, we can define rate in two different ways now. For example, thus rate of reaction with respect to reactants Thus rate of reaction with respect to reactants is defined as this is a rate rate with respect to reactants, it is equal to negative dC by dt. So why it is negative sign indicating before the dC means it is representing negative sign represented decrease in concentration of reactants. So it is equal to what now this one? This is minus means decrease in concentration of reactants. Decrease in concentration of reactants per unit time interval. Or change in time. So this is the rate with respect to reactants. Because as time increases, concentration of reactants gradually decreases. So this particular graph indicating as time increases, concentration of reactants decreases, at the same time concentration of product is increasing. That's why we have two definitions to rate na. So rate with respect to reactant is minus dC by dt. It is decrease in concentration of reactants per unit time interval or change in time. Negative sign here representing decrease in concentration of reactants. At the same time, rate of reaction with respect to products, we can define in another way na. So rate of reaction with respect to products is again defined as rate is equals to plus dP. P means product, dP by dt. Here plus sign indicating the increase in concentration of products. Therefore, plus dP means increase in concentration of products upon change in time interval, or this is the change in time or time interval. Therefore, rate is equal to plus dP by dt means increase in concentration of products upon change in time or time interval. So here plus sign indicating the increase in concentration of products. So there are two different types of definitions to rate. One is rate with respect to reactants, and another is rate with respect to products. So this is basing on one concept, simple concept, that is in any chemical reaction, concentration of reactants initially it is high, and at the same time concentration of product is 0. As time increases, rate of reaction gradually, that is concentration of reactants gradually decreases. At the same time, concentration of products gradually increases. So basing on this rate of reaction, we can define in these two ways. Rate is equal to minus dC by dt and rate is equal to plus dP by dt. So minus sign, minus dC by dt means decrease in concentration of reactants upon unit time interval or change in time. So negative sign representing decrease in concentration of reactants. So with respect to product, it is plus dP by dt. So increase in concentration of products upon change in time or time interval. Here plus sign indicating what na? This is increase in concentration of products. Now let us the same rate of reactions for stoichiometric equations. How can we write the stoichiometric equations? Rate of reactions. Rate of reactions for stoichiometric equations. How can we express rate of reactions for stoichiometric equations? Suppose reactions which contain two or more reactants or products, we can equalize the rates as follows. For example, you take the A plus B gives product P. This is the one stoichiometric equation. So in this particular stoichiometric equation, 1 mole of A reacting with 1 mole of B to form a product, single product now. So for this reaction, how can we equalize the rates? So now this is the reactant, therefore you place negative sign before the rate of reactant A, because rate is decreasing, therefore you must place negative sign before the dA by dt, and this must be equal to negative dB by dt. This is the rate of reactant B, and these two rates must be equal to the product, but you place before the rate dP by dt, place positive sign now. So this particular concept is basing on rate in any chemical reactions, rate of disappearance must be equal to rate of appearance. So basing on this, we can write these rates. Here A is the reactant, B is the product, and P is the product. A is the reactant, B is the reactant, but P is the product. But how can we equalize the rates? This is 1 mole and this is also 1 mole. Therefore, we can equalize the rates. Minus dA by dt is equal to minus dB by dt. It is equal to plus dP by dt. It is basing on what now? This is rate of disappearance of reactants is equal to rate of appearance of the products. For example, if you take the 2A plus 3B gives product 4D. So how can we equalize the rates? Here these are the stoichiometric coefficient 2, here stoichiometric coefficient 3, here stoichiometric coefficient 4. But rate of 2 moles of reactant A is not equal to the rate of 3 moles of the reactant B. But you have to change some. This is the stoichiometric coefficient of the reactant A now. So therefore, you must place negative sign before the rate of before the rate of reactant A. This is the reactant A rate, but you take the reciprocal of the 2, that is 1 by 2 must be equal to the reciprocal of the rate of reactant B, reciprocal of the stoichiometric coefficient of the reactant B. Therefore, minus 1 by 2 dA by dt must be equal to the minus 1 by 3 dB by dt now. And here we have a, this is the product, therefore you must place positive sign before, because the concentration of reactant D is increasing. Therefore you place positive sign, and reciprocal of the 4 is 1 by 4, and the rate of product D is dd by dt. Suppose if you take the one chemical reaction, this is the decomposition of the N2O5, gives 2 moles NO2 and half mole O2. So for this reaction, how can we equalize the rates? So this is the reactant, 2NO2 is the product and half O2 is also product. Therefore, rate of N2O5 it is minus dN2O5 by dt. But here we have 2 moles. For 1 mole rate of N2O5 is equal to 1 mole of the rate of NO2, but here we have 2 moles. Therefore, you take it is a product, that's why this is the positive sign, and reciprocal of the 2 is the 1 by 2 and dNO2 by dt. This is the rate of NO2, and it is equal to positive reciprocal of the 1 by 2 is the 2, therefore 2 into dO2 by dt. So this is the way to write stoichiometric rate equations for reactions which contain 2 or more reactants or products. So again I will explain this one. So rate of reaction for stoichiometric equations. So reactions which contain 2 or more reactants or products, for that only it will be useful. So for that we can equalize the rates. For example, if you take the A plus B gives product P, A and B are the reactants, P is the product. So here this is the reactant, therefore you must place negative sign before the rate of reactant A. Minus dA by dt is equal to minus dB by dt, and this is the product, that's why you place a positive, and rate of P is the dP by dt. So this is basing on what now? Rate of disappearance of any reactant must be equal to rate of appearance of any product in any chemical reactions. This is the correct one. That's why rate of disappearance is equal to rate of appearance of the products. So for that, suppose if you take the 2A plus 3B gives 4D, this is the one chemical reaction. So for that you place negative because it is a reactant, minus, and reciprocal of the 2 is the 1 by 2 and this is dA by dt. It is equal to the rate of this reactant A of 1 by 2 is equal to rate of reactant B with 1 by 3. Therefore here minus dA by dt we can write as minus dA by dt, it is equal to 2 by 3 minus 2 by 3 dB by dt. So in this way also we can write minus dA by dt is equal to minus 2 by 3 into dB by dt, or it is equal to minus this is plus 2 by 4 dd by dt also correct now. So this is the minus dA by dt is the rate of reactant A only. It is equal to 2 into cross multiplication. By cross multiplication 2 minus 2 by 3 dB by dt, or minus suppose if you cross this one 2 into 1 2 by 4 dd by dt also, it is equal to minus dA by dt. For example, N2O5 gives 2NO2 plus half O2. So minus dN2O5 by dt, it is equal to, this is the product, that's why you place plus, and reciprocal of the 2 is the 1 by 2 dNO2 by dt. And it is equal to, again this is the reciprocal of the 1 by 2 means 1 by 1 by 2 means 2, and this is a product, that's why we place the positive sign before the dO2 by dt. So this is the way of writing rate of reactions in case of stoichiometric equations. Now let us discuss the determination of rate of reactions. Determination of rate. So generally we have two different types of rates. One is the average rate and another is the instantaneous rate. There are two different types of rates. So rates are two types. One is rate average. So this is RAV. RAV is the rate average. Number 2 is the instantaneous rate. There are two different types of rates we can calculating for chemical reactions. One is the average rate of reaction, another is the instantaneous rate of reaction. Instantaneous rate of reaction. This can be represented by R instant. So what is rate average? So average rate, how can we determine the average rate? So first one, it is the average rate of the reaction. Average rate of reaction. So what is meant by average rate? For a chemical reaction, generally we can rate in between some time interval. So for example, actually concentration of reactants or products, concentration of reactants on y-axis and time t on x-axis. When a graph is plotted between the concentration of reactants on y-axis and time t on x-axis, we get a curve like this. Initially, concentration of reactants is very high. This is the concentration of reactant at time t equal to 0, means very high. As time increases, concentration of reactant gradually decreases. So for this, how can we determine the rate average? For example, this is the time t equal to 0, this is at 5 minutes, this is at 10 minutes, and this is at 15 minutes, and this is at 20 minutes now. And initially this is the 0.1 moles per liter. Concentration of reactant is concentration of reactant, it is here, if you assume this as 0.1, this is 0.2, and this is 0.3, and this is the 0.4 moles per liter. 0.4 moles per liter. So this is 0.1 moles, this is 0.2 moles, this is 0.3 moles, this is the 0.4 moles. This is the concentration of reactants. This is the concentration of reactants. This particular symbol is representing the concentration, and this is the reactant concentration on y-axis. This is on x-axis. What now? This is time. So initially concentration is very high. As time increases from left to right, what is happening now here? This is the decreasing in concentration of the reactants. Now let us we determine the average rate between the 10 to 15 minutes. Average of the rate between 10 to 15 minutes. Therefore, for this, this is at 10 minutes, this is at 15 minutes, and the slope of this one it is the slope of at 15 minutes concentration of reactants is like this. At 10 minutes this is the concentration of the reactant is 0.2 now. Suppose this is 0.1 and it is this is 0.1 moles per liter, and this is the 0.2 moles per liter, and it is 0.3, this is 0.4, this is what now? This is concentration of reactants. At time 15 minutes we have the concentration of the reactant is 0.1 moles per liter, and at 10 minutes concentration of the reactant is 0.2 moles per liter. Therefore, rate average it is equals to the time change, or this is the change in time, it is represented by dt, and this is the change in concentration, this is delta C or dc. This is the dc and this is the delta t. Therefore, R average it is equal to minus delta C by delta t. Why it is minus now? Because it is the rate with respect to reactants. Therefore, you must place a negative sign before this is the rate average. Rate average is equal to negative minus delta C by delta t. What is minus? This is minus delta C means at 15 minutes. At 15 minutes we have the 0.1. This is suppose if it is C1, this is the C2. C1 is the concentration of reactant at 15 minutes. At 15 minutes concentration of reactant is C1. At 10 minutes concentration of reactant is C2. Therefore, C1 minus C2, delta C means C1 minus C2 by, and delta T means 15 minus 10. It means T2 minus T1. So now we can write it as what now? Negative. C1 is what now? This is 0.1, and C2 it is 0.2, and T2 means this is the T2, this is the T2, and this is the T1. So 15 minus 10. Therefore, 0.1 minus 0.2 means what now? This one, this is the 0.1. Minus 0.1 into 0.1, minus 0.1. by this is 5. So it is equal to 0.1 by 5. This is mole liter inverse, because it is a rate, mole liter inverse and minute or time inverse or second inverse, whatever it is. Suppose if you take this is in minutes, it will be minutes. Suppose if you take this is seconds, it will be in seconds. So this is the way of average rate. Average rate, nothing but what now this is? What is average? Average of the reactants, average rate of the reaction. Average rate of the reaction is defined as what now? In between some time interval, we calculating the rates. At 15 minutes we have the 0.1, at 10 minutes we have the 0.2. So in between this gap, how much of rate is there? That is the rate average. This is what now? 0.1 by 5 mole liter inverse minute inverse. And what about the instantaneous rate? Actually, instant means instant of time. So what is instant of time? So instantaneous rate. Instantaneous rate means rate is defined as instantaneous rate of reaction. So what is instantaneous rate of reaction? So R instantaneous is defined as rate at a particular time, particular instant of time. For example, if you want rate at 5 minutes, or if you want rate at 10 minutes, or if you want rate at 15 minutes, so that is the instantaneous rate. Actually, instantaneous rate in this method, a graph is plotted. A graph is plotted between concentration of reactants or product. Concentration of reactants or products on y-axis and concentration of reactant, not concentration, this is time. Time t on x-axis, we get a curve. So that is this is the y-axis, this is x-axis. On this we take a concentration of reactant on y-axis, time t on x-axis. So now you will getting like the same like this. Okay, but how can we determine the rate at a instant of time? For example, if you want this particular time, for example, this is the 5 minutes, this is the 0 minutes, this is the 10 minutes, this is 15 minutes, this is 20 minutes. But how can we calculate the rate at one fixed point? This is a fixed point. So for this we drawn a tangent. This is the tangent line. This is the tangent line, and this the particular tangent line touching this curve at a particular time, 5 minutes. And this particular line is also touching y-axis at this point and also x-axis at this point. Now this is 12.5. This is, for example, this is the 0.1, this is 0.2, and it is the 0.3. So now how can we calculate the instantaneous rate of this particular reaction? R gives P product. At a 5 minutes of time now, R instantaneous, this is the curve we obtained when a graph is plotted between the concentration of reactants on y-axis, time t on x-axis. We get it like this curve. A tangent line is drawn such that it touches the y-axis, also x-axis, and also the curve at a point at which time is 5 minutes. Now, how can we calculate the rate instantaneous? So, for a tangent line, slope is equal to tan theta. So, tan theta is equal to slope. So, how can we, what will the slope of the reaction now? What is the slope of this tangent line? The line where it touches the x-axis from here to here. From here to here, this is the dt. The line where it touches, the tangent line where it touches now, here it is. So, therefore, here 0, this is 12.5. This is equal to dt. The line where it touches the y-axis, from here to here it is, what now this one? This is dc or dr. So, r instantaneous, it is equal to dc or dr. This is the concentration of reactant, or this is the concentration of reactant, by dt. This is the change in time. So, here what now this one? This is equal to 12.5. The line where it touches the x-axis is dt. The line where it touches the y-axis, it is the dc. Therefore, dc by dt, it is what now? Slope of the tangent, which is equal to instantaneous rate. So, this is 0.3 and dt, it is the 12.5. Again, it is the same mole, liter inverse and time inverse. So, this is the r instantaneous at a particular time, at a instant of time, that is 5 minutes. At a particular time or at a particular instant of time, here we are calculating the rate of reaction. Therefore, this is the instantaneous rate of the reaction. So, rate instantaneous is defined as rate at a particular instant of time. In this method, a graph is plotted between the concentration of reactants on y-axis and concentration of reactant on y-axis, time t on x-axis. We get a curve like this. So, in this method, a tangent line is drawn. A tangent line is drawn. This is the tangent line. This touches the x-axis and also y-axis and also curve at a instant of time, at a given time, that is 5 minutes. Therefore, it is the instantaneous rate at 5 minutes. This r instantaneous at what time now? This is at 5 minutes. At 5 minutes, we can calculating dc by dt. dc means the tangent line where it touches the y-axis is the dc, the line where it touches the x-axis is the dt. So, it is equal to slope of the tangent, that is why dc by or dc or dr by dt, it is 0.3 by 12.5. So, this is the way to calculate the instantaneous rate of the reaction. And next, what is the units of rate? Units of rate. What is units of rate? So, rate, it is nothing but what now? R is equal to dc by dt. So, dc means change in concentration. Change in concentration. And this is change in time. Change in time. So, change in concentration is nothing but what now? Concentration. We can simply take concentration, this is the time. Therefore, concentration units are moles per liter. Moles per liter, and this is the time, means time only. So, time may be minutes, seconds, years, days, whatever it is. Therefore, it is equal to mole, liter inverse and time inverse. So, this is the units of rate. Units of rate, it is equal to what now? Mole, liter inverse, time inverse. So, again I will explain. R is equal to dc by dt, change in concentration of reactants or products upon change in time or time interval. So, change in concentration, simply we can say it is concentration, change in time means time. Concentration units are moles per liter and time units are time or days, years, maybe whatever it is now. Therefore, mole, liter inverse and time inverse is the units of rate. And then, for example, a question is like for a chemical reaction, N2O5 gives 2NO2 plus of O2. Rate of disappearance of N2O5 is 0.5 into 10 to the power of minus 2 mole liter inverse minute inverse. So for a chemical reaction, N2O5 gives 2NO2 plus half O2. Rate of disappearance of N2O5 is 0.5 in 10 to the power of minus 2 mole liter inverse minute inverse. Then calculate the rate of formation of NO2 and O2. So how can we calculate the rate of formations of NO2 and O2? To calculate this, we must write rate equations, rates of N2O5, NO2 and of O2. How can we write the stoichiometric rate equations? So this is the reactant, that's why you place before N2O5 rate negative dN2O5. This is the rate of N2O5, or this may be also rate of disappearance of N2O5. And this is the product, that's why we can place the positive before NO2 rate, and here this is 2 moles, that's why 1 mole of rate of N2O5 cannot equal to the 1 mole of the 2 moles of the rate of NO2. That's why you take the reciprocal of this 2 and NO2 by dt. It is equal to 1 by 1 by 2 means plus 2 dO2 by dt. This is the stoichiometric rate equalizations. But this one is given. So negative dN2O5 by dt it is given, that is equal to 0.5 into 10 to the power of minus 2 mole liter inverse minute inverse. It is given. And how can we calculate this one? 1 by 2 dNO2 by dt. So we want only the rate of formation of NO2. So rate of formation of NO2 is 1 plus dNO2 by dt. This is the rate of formation of NO2. Rate of formation of NO2 is this one. It is equal to what? Cross multiplication of this 2 into this 0.5. So 2 into 0.5 into 10 to the power of minus 2 mole liter inverse and minute inverse. So this is the rate of formation of NO2. And again rate of formation of O2 we want only now. So plus dO2 by dt we want. But actually plus dO2 by dt it is equal to what now? Cross multiplication. Minus 1 by 2 dN2O5 by dt from the equation, from this equation. So plus dO2 by dt it is equal to cross multiplication minus 1 by 2 dN2O5 by dt. But this one is given minus dN2O5 by dt, it is already given now, therefore it is equal to 1 by 2 into 0.5 into 10 to the power of minus 2 mole liter inverse and minute inverse. So this is the way to calculate the rate of formations of NO2 and O2. Again I will explain now. For a chemical reaction, N2O5 gives 2 NO2, 2 moles NO2 and half mole O2. This is the reaction given. For this reaction, rate of disappearance of N2O5 is only given. This one is given. Rate of disappearance of N2O5 is given. So rate of disappearance of N2O5 it is how much now? This is 0.5 into 10 to the power minus 2 mole liter inverse minute inverse. Therefore, you must calculate the rate of formation of NO2 and O2. To calculate the rate of formations of NO2, O2, first you write the rate equations. This is the rate of N2O5. It must be equal to plus 1 by 2 dNO2 by dt as per the stoichiometric equations. And it is equal to reciprocal of the 1 by 2 means 2 dO2 by dt. So basing on this, this is given na, this is 0.5 10 to the power minus 2 mole liter inverse meter inverse, it is equal to plus 1 by 2 dNO2 by dt, but we want only the plus dNO2 by dt, plus dNO2 by dt, it is equal to rate of formation of NO2, it is equal to 2 into this one, 2 into this 0.5 into 10 to the power minus 2, that's why this is the rate of formation of NO2, and this is dO2 by dt, this is the rate of formation of O2. Rate of formation of O2, it is equal to minus 1 by 2 dN2O5 by dt from this equation. So already minus dNO2 by dN2O5 by dt, it is equal to 0.5 10 to the power minus 2. By 1 by 2 it is there, therefore 1 by 2 into this one. Therefore it is 0.5 into 1 by 2 means 0.25 into 10 to the power of minus 2 mole liter inverse meter inverse. This is the way to calculate the rate of formations of NO2, O2 in a chemical reaction if rate of disappearance of N2O5 is given. Now let us we calculate the units of different orders. So before we go into this one, the second term, first term it is over now, first term is the rate of reaction is over. Now this is the second term, that is the law of mass action. So law of mass action or rate law, not law of mass action, this is a rate law. So what is meant by this rate law? So rate law, this was proposed by Vaughey. So according to this rate law, according to this rate law, the rate of reaction is directly proportional to product of concentrations of reactants, product of concentrations of reactants and each reactant concentration is raised to the power of stoichiometric coefficients. This is what now? This is a law of mass action. Actually, this is law of mass action. According to rate law is what now? This is according to law of mass action. This one. Law of mass action means LOMA. So what is according to law of mass action? The rate of reaction is directly proportional to product of concentrations of each reactants, and each reactant concentration is raised to the power of their stoichiometric coefficients. For example, let us consider a chemical reaction. A plus B gives rise to CC plus DD. This is the one stoichiometric equation. So according to this law of mass action, so rate of reaction is directly proportional to product of concentrations of reactants, product of reactant concentration A into product of reactant concentration B, and each reactant concentration is raised to the power of their stoichiometric coefficients, power A and power B. This is rate of reaction. So rate of reaction, it is simply R, it is directly proportional to R, this one R is equal to one constant k into a power a and b power b. This is the rate equation. This is the rate equation as per the law of mass action. This is the rate equation as per law of mass action. But according to rate law, rate of reaction is directly proportional to product of concentrations of reactants, and each reactant concentration is raised to the power of their experimental coefficients x and y. Therefore, rate of reaction is equal to one constant k into a power x and b power y. A power x into b power y. Here x and y are the practical coefficients, experimental coefficients. So rate of reaction is directly proportional to the product of concentrations of each reactants. Here reactants are what na? A and B are the reactants. And here A and B, small a, small b are the stoichiometric coefficients. Here small a and small b are stoichiometric coefficients. Whereas according to rate law, rate of reaction is directly proportional to the product of concentrations of reactants, and each reactant concentration is raised to the power of their experimental coefficients. Therefore, rate of reaction is equal to one constant k into square bracket a power x into square bracket b power y, where square bracket a, square bracket b are the molar concentrations of the reactants A and B, and x and y are the experimental coefficients. So from this, from rate law, rate is directly proportional to a power x and b power y. So this is rate is equal to constant k into a power x and b power y, where k is the rate constant, and x and y are the experimental coefficients. So this is rate law. So rate law is expressed in this way. Rate is equal to k into a power x into b power y. For a chemical reaction, A plus BB gives rise to Cc plus Dd. This is the rate equal to k into a power x into b power y. This is the rate law. And now, what is rate constant? Rate constant k is what? So consider a chemical reaction. Consider a chemical reaction. A plus B gives product P. For this, according to rate law, rate is directly proportional to A power some x and B power some y. So here x and y are the experimental coefficients. So rate is equal to one constant k into A power x, again same B power y. And k is equal to what now from this? K is the rate constant. It is equal to 1 by R. K is equal to, this k is equal to R by k is equal to, k is the rate constant, it is equal to 1 by A power x and B power y into rate by A power x into B power y. This is the k. So how can we define this rate constant K? So what is rate now? Rate is equal to dx by dt. K is equal to 1 by a power x and b power y into rate. Rate means what now? Dx by dt or dc by dt. But what is K? K is the rate constant. How can we define this K? When concentration of reactant A, when concentration of reactant A equal to concentration of reactant B and x is equal to y. Suppose so this is you take the x and y are same. So R is equal to 1 K into A power square bracket A into square bracket B. Now this one so K is equal to rate by concentration of reactant A into concentration of reactant B. Now how can we define K? K is the rate constant. K is rate constant. So K is defined as what now? When concentration of reactant A equal to reactant B. This is the definition of rate constant now. So K is defined as rate. K is defined as rate. K is defined as rate when concentration of reactant A is equal to concentration of reactant B equal to 1 or unity. That means K is equal to rate and concentration of reactant A and concentration of reactant B both are equal and equal to 1. Therefore 1 into 1. Therefore K is equal to rate only now. So K is equal to rate. What is K? K is rate. K is defined as rate when concentration of each reactant becomes equal to 1 or unity. So in this condition only we can defining what now? Rate constant K. Consider a chemical reaction. A plus B gives product P. According to rate law, rate is equal to K into square bracket A into square bracket B. This is according to rate law. So from this we writing for only K now. K is equal to what now? Rate by concentration of reactant A and concentration of reactant B. If concentration of reactant equal to concentration of B is equal to 1, then K is equal to rate or not? K is defined as rate when concentration of reactant A is equal to concentration of reactant B is equal to 1 or unity. Then K is equal to what now? Rate by 1 into 1 or K is equal to rate. So this is the way to defining rate constant now. So after this, so we defined rate and we defined rate law and we defined again rate constant. Now it is the time for order of a reaction. What is order of a reaction? Order of a reaction. For example, let us consider a chemical reaction Ma plus Nb gives product P. This is the one chemical reaction. So if you have any doubt, please call to me my number, that is 868610. Okay. So if you have any doubt, please call to me the scroll number na Contact your contact the scroll number. Okay. So let us consider a chemical reaction. Ma plus Nb gives product P. This is one chemical reaction now. So for this, how can we calculate the order of a reaction? So to determining the order, first you know what is meant by order. So order is defined as so according to rate law, rate is equal to one constant k into a power m and b power n. This is rate law for this Ma plus Nb gives product P. So here k is the rate constant, r is the rate concentration of A, this is concentration of B, this is the power raised to m, this is power raised to n. So order of this reaction is equal to sum of powers of concentrations of reactants m plus n. This is the order of a reaction. So how can we defining this order of a reaction? This is the, it is defined as okay. So it is defined as a sum of powers of concentrations of reactants expressed in rate law. So basing on this definition, what will be the order now? So sum of powers, sum of powers means m plus n is the order of this reaction. Therefore sum of powers of concentrations of reactants expressed in rate law, this is the rate law. In this only the sum of powers of concentrations of the reactants is nothing but what? Order of a reaction. So in the next class we will discuss the remaining part. If you have any doubt, please ask or you contact the scroll number. Okay. ఓకే సో మీకు ఏమైనా డౌట్స్ ఉంటే ఆ స్క్రోల్ అవుతున్నటువంటి నెంబర్కి మీరు కాల్ చేయండి. ఓకే సో మీకు ఇప్పుడు ఏమైనా డౌట్స్ ఉంటే మమ్మల్ని అడగండి, ఆన్సర్స్ కూడా నేను ఇప్పుడే చెప్పగలుగుతాను. ఓకే లేకుంటే మీరు ఆ స్క్రోల్ నెంబర్కు చార్జ్ చేసినా నో ప్రాబ్లం, ఆర్ కాల్ కూడా చేయొచ్చు. So please ask if you have any doubt. So I will close my class now. Hello?
Hello, sir.
Sir, please tell me, sir.
Can you please explain me about the order of reaction?
You want the order of reaction? Okay. Okay, sir. Thank you very much. So order of a reaction is nothing but what now? This is defined as sum of powers of concentrations of the reactants. Sum of powers of concentrations of reactants expressed in rate law. So you must know what is rate law first. So for a chemical reaction, for any chemical reaction, for example, Ma plus Nb gives product P. So for this reaction, you must apply the rate law. rate law, according to rate law, rate is equal to one constant k into a power m and b power n. So according to this rate law, the sum of powers of concentrations of reactants, this is the reactant concentration A, this is the reactant B concentration, and their power is m here, their power is n is here. Therefore, you must add both the powers of reactant concentrations A and B, then it will be equal to what now? Order. Therefore, order is the sum of powers of concentrations of reactants expressed in rate law. So, this is the order of a reaction. Generally, order of reactions are, we have order of reactions are what now? These are the reactions. Reactions means zero order reactions. It may be first order reaction and second order, third order, and nth order. There are various orders of the reactions now. Okay. If you have any question, again ask now. Otherwise, I will close my chapter now. I will close my class. Okay. Okay.